Solution of a quadratic equation by completing the square. In this module, we will learn about solution of a quadratic equation by completing the square. Solving quadratic equations by completing the square. General form of quadratic equation is ax square plus bx plus c is equal to 0. Where a is coefficient of x square, b is the coefficient of x and c is the constant term. Let us solve it by completing the square. Solving a quadratic equation by the method of completing the square can be divided into following steps. Step 1. Divide all terms by a, the coefficient of x square. Step 2. Move the number term c upon a to the right side of the equation. Step 3. Complete the square on the left side of the equation by adding whole square of b upon 2a and balance this by adding the same value to the right side of the equation. Step 4. Complete the squares by making use of identity whole square of a plus b is equal to a square plus 2ab plus b square. Step 5. Take square root on both sides of the equation. Step 6. Solve for x once taking the value on RHS as positive and once negative. Let us take an example for better understanding. Solve the quadratic equation by completing the square. 2x square minus 5x plus 3 is equal to 0. Let us solve. Here, a is equal to 2, b is equal to minus 5 and c is equal to 3. First step, divide throughout by 2 as here coefficient of x square a is equal to 2. We get x square minus 5 upon 2x plus 3 upon 2 is equal to 0. In second step, moving c upon a, that is 3 upon 2 to the right side, we get x square minus 5 upon 2x is equal to minus 3 upon 2. In third step, complete the square. Add whole square of b upon 2a, that is whole square of 5 upon 2 into 1 upon 2 is equal to 25 upon 16 to both sides of the equation. We get x square minus 5 upon 2x plus 25 upon 16 is equal to minus 3 upon 2 plus 25 upon 16. In step 4, write the left-hand side as perfect square using the identity whole square of a plus b is equal to a square plus 2ab plus b square and simplify right-hand side. We get whole square of x minus 5 upon 4 is equal to 1 upon 16. In step 5, taking square root on both sides, we get x minus 5 upon 4 is equal to plus minus 1 upon 4. In step 6, solve for x once taking the value of RHS as positive and then as negative. Therefore, x minus 5 upon 4 is equal to plus minus 1 upon 4. Moving 5 upon 4 to the right side, we get x is equal to 5 upon 4 plus minus 1 upon 4. This gives x is equal to 5 upon 4 plus 1 upon 4 or x is equal to 5 upon 4 minus 1 upon 4, which implies x is equal to 3 upon 2 or x is equal to 1. Therefore, the solutions of the equations are x is equal to 3 upon 2 and 1.